It's PCB project day, and today I am building a Touch Light Dimmer. Let's get into it. Yes, people, welcome to Teaching Myself Electronics. My name is Lex, and today we'll be doing a little hands-on building a Touch Light Dimmer, a tiny little project I picked up from AliExpress. This is what the final product should look like, and this is how it should work. And no, this is not me. This is just a promotional video that I got from the website. So hopefully we can achieve this. But before we get into it, please hit that thumbs up button to like the video, and please also subscribe to the channel. Your support goes a long way, and we have a lot more to come. Thank you in advance. Let's go. Alright, so the PCB light dimmer, a tiny little project. It's not expensive. It's fairly cheap. I think it costs about $2 on AliExpress. Come with a few components. So you have the PCB board in a shape like a disc, circular disc format, with a fingerprint symbol in the middle for the touch. And I have these yellow things. I think these might be the lamp. Yeah, these might be the lamp that going light up. For IC chip, I have some resistors. I see here I have some capacitors. Yeah, it's not a lot of parts. A few parts. Shouldn't take me that long, but you know, nothing is ever easy. Alright, so just starting out the resistors here. It looks like I have about 6 resistors. Now I'm going to test the values for these because I don't know what value they are. They're not labeled, of course. So yeah, then we have this look like a capacitor, and I think this other one is a capacitor as well, but why we need 2 different capacitors? Hold on, I need to check that out. Need to understand why we need these 2 type of capacitors and exactly what type of capacitors they are. I know they are capacitors, but don't know exactly the purpose for each of them. So let me just look them up and see real quick. Let's start off with the orange looking round capacitor. This one is a ceramic capacitor. It filters high frequency noise, stabilize the circuit, and help prevent false touch detections. So that's the orange flat one. Alright. Alright, so the black cylinder type one is electrolytic capacitor, and they said this one stores electrical energy, smooths the power supply, and reduce voltage fluctuations. So everything else should be pretty straightforward. I have the capacitors, the resistors, I have the yellow lamps, and I have the legs. So, well, we have the IC chip as well. I almost forgot that, but we all know that that's the actual brain of the project, and it will determine and detect the touch based on sensor controls to enable maybe to enable the LEDs to light up. Alright, let's get started. Which one of these LPNs I'm gonna use? I think I love the magnetic LPNs, but I think I'm gonna use the clamp LPNs for this one because I like the rotation that it offers, and this would allow me to easily put the components in, rotate, and solder. So yeah, for this one I'm gonna go with the this clamp LPNs. One thing, it's a bit high though, and it comes kind of close to the microscope. But apart from that, I actually like using it. So looking at these yellow lamps, trying to determine where is positive and where is negative. It's not engraved on it. I notice one of the legs are longer, one is shorter, and what I'm used to normally is the long leg is the positive, right? But you know what? Let me get the instructions and see what's going on with this. Alright, few languages, find the English version, and let's. Alright, so it said the lamp is made of ceramic materials and easy to break. Handle it with care. The short pin of the lamp is positive and the long pin is negative. Short pin is positive. Yeah, that sounds kind of backwards. I'm normally used to the long pin being positive, the short pin being negative, similar to on a LED, but this is the instruction, so we go by them, I guess. Here, the welding assembly to avoid damage to the lamp, sound of the lamp last. Alright, so that's good. It's an input voltage 5, DC 5 volt. I don't have a 5 volt, I have a 9, but that should work. Resistance, use a multimeter to measure. Check resistance value through resistance color. No, I'm not using the color. I'm going to use the multimeter for that one. It says by pressing less than 0.5 seconds, the touch button, you can easily turn the light on and off. Okay, so that's the instruction just to operate the light. Alright, let's check the other side. Alright, just some different languages here, same instructions. And then below we have the schematics and the finished product. Alright, so we should be good then. Should be able to start this now. Alright, all clamped up. Which component should I solder first? Resistors crying out to me. I mean, that's the last video I did, so I think I'm just gonna go ahead and solder the resistors. Alright, let's get the resistors on one side, on in one place, and then we can start testing them. On the PCB board, I can see that the type of resistors to use. All the components are labeled. So right now I'm trying to find the 100 ohm, and then I'll just I'll just put them in one at a time and then solder them when I'm all done testing. So just using the multimeter now in diode mode or continuity mode, try to find each of these resistors, put them one at a time and then solder them. So I find the first 100 ohm here. This is the very first one. And so in all we have 6 resistors. Let's see if I can get these all in, measured properly, and then start some soldering. Would it be faster to use the color code or to use the multimeter? For me, the multimeter is faster. So this is my preferred way of doing it. Going well. So I made a simple rookie mistake here. I'm trying to find the 47K resistor, but I couldn't find it. Every time I measure this resistor, I'm getting 100 ohms. And I know I tested the rest of the resistors correctly, and I know I installed them in the right place. But I went back for the manual, I counted the resistors again. It was only after I checked the schematic I noticed that there was only one 47K resistor, and I installed it correctly. And so I had in my head that there was 2, but it was 1. The rest of them was 100 ohm resistors. So 5 100 ohm resistors, 1 47K resistor. The other 47 was a 47 UF capacitor. It wasn't a resistor. So the first 47K resistor, I'd installed it at the 47 UF capacitor section. That's why I ended up with the last resistor being a 100 ohm, and there was a slot there for the 47K and I couldn't find it. But check the schematic, everything makes sense now. So I'll remove the 47K resistor from the 47 UF section, put it in the 47K section, and then the 100 ohm resistor go to the right place. So now I have the section there for the 47 UF capacitor that I'm going to install. So we're all good now. Time to solder. Let's go. Alright, so we're going to get some flux. So we're ready to solder. I have some flux. I have my solder iron ready. I have my solder wire. I wish I had some of the 0.6 millimeter wire. I only have 0.8 for now. I did order the 0.6, but I don't receive that yet. So 0.8 should do for now. Hey, you know what? I'm actually getting to like this solder tip, you know. This bend solder tip. I call it the bendy tip. Yeah, it's getting to some hard to reach places, and the tip is small. I mean, the bevel and the knife tip are, kind of still my favorite, but yeah, this bend tip is really growing on me. I'm really liking it. Alright, soldering off all resistors are done. Let's clip them up. Alright, that's done. Let's turn them around and take a look. See what it's looking like. Yep. Resistors. Yeah, one crooked. One's not laying so flat, but I mean it still works, eh? Can give that one a pass. Alright, so what next to solder now? Should we do capacitors? Yes. Let's do the capacitors. Alright, so this one is the electrolytic capacitor. This one, this is store energy, of course, and it reduces voltage fluctuations. So the plan is pretty much every time I do these projects and I meet a component that I know, or even if I know it, because I know these are capacitors, but I don't know exactly what this type of capacitor is doing. So this one is reduced fluctuation. So I guess it's keeping a steady flow of voltage. So that's the plan. Every time I don't know, I just want to do a quick research and try to figure out exactly what it's used for. Alright, so I just almost made another rookie mistake. I just realized something before it happened. I was gonna solder I was gonna install and solder the capacitor, but I have an IC chip to install. I forgot about that. And because I'm gonna use a heat gun on this little PCB board, I think it's best if I install the IC first, then do the capacitors, and the rest of the stuff last. Alright, let's move over to the IC. Yeah, we know the drill. Add some flux, add some solder to the pads, line up the pins, pin 1 to pin 1, use some heat. So flux is on, so I'm adding some solder with the solder wire. But you know what I never tried? I never tried high temp solder piece. And I think that would be good to install ICs and chips like this. I've seen it done in videos where it just shift the chip into place. I ordered some, I don't have it yet. I need to try high temp solder paste when installing these chips. I think it might make it a bit easier. Alright, so we have some solder on. I'm just gonna see if I can line them up properly now, and then add some heat. That look good. That should be good enough lined up. I'm gonna add some flux, and then I'm gonna bring in the heat gun at around 370 degrees Celsius. That should do it. Alright, so I'm gonna apply the gel type flux because I like this one because it stays together more and it don't get blown off easy as the liquid one. Alright, time for some heat. And you know the drill as well. Circular motion, heat at 370 degrees. Sometimes I like to use a tweezer just to hold the chip in place sometimes. And apply the heat until the solder and the pins melt, and then we should be good. Alright, that look good. Let's give it a little nudge. Yep, solid. Alright, nice. Let's flip him over and see what else we have to install, or what next we're gonna install. Alright, so looking at this, I just realized that I actually have a transistor. Yeah, this looks like a transistor. I mistook it for a capacitor earlier. So I think we need to get this one in and see if we can get this installed before we move on to the capacitors. Yeah, but before I move on, I have to look up what this transistor does. What is it being used for in this project? So let me do a quick research and see what's going on here. Alright, so it said this electronic component appears to be a T092 transistor or emitter, frequently used in circuit prototyping. Also says used to switch current to LEDs or regulate the circuit's voltage depending on the design. Okay. Alright, so a 3-pin transistor, T092. That's what this transistor is. This transistor have to be installed the correct way. It can't be installed in any order. But notice on the PCB they have the shape. They have it in a like a 3/4 of a circle type of shape, so that you can match the shape of the transistor and align it accordingly. So I'm gonna do that and get it in, and then see if I can solder it into place. Alright, ready for soldering the transistor. Some flux, some solder. Get these 3 pins connected so we can move on to the capacitors. A bit of too much flux on the board. It's getting kind of sticky, so I'm gonna see if I can clean off some of this flux so I can make it a bit easier to work with the rest of the components. Alright, long overdue. Time for the capacitors. Alright, so we have 5 capacitors in all. We have the 2 black cylinder 47 UF capacitors and the 3 orange round ceramic capacitors. So I'm just going to install all 5 together one time and then just do one quick soldering for all 5 of them. I think it's easier that way. Just clean up the area a bit here. I noticed some flux was still here, so just making sure it's clean before I drop these capacitors in. Alright, so done cleaning up. Gonna put the capacitors in now. But I know which capacitors go where. On the PCB board, they are labeled on there, the 100 UF, the 100 NF, and so on. Also, this schematic can tell me as well, but I'm just using the label on the board for now. And there's also a tiny label on the capacitors themselves with the value and the number for each capacitor. And the capacitors are now in, all 5. The 247 NF cylinder capacitors, black cylinder capacitors, and the 3 orange ceramic capacitors. So we have 2 100 UF and a 10 UF, I think it is. Right, so all 5 are in. Now we should just get the pins sorted out and the legs, pretty much. Get the legs sorted out in order, add some flux and then solder them. Add some flux to all the legs. Now I'm gonna just go through with the soldering. Sometimes I wish I had another solder station with like a different tip. Still using the bendy tip here, don't mind it, but I also like the bevel tip and the knife tip. But just saying, if I had another soldering station, I wouldn't have to change the tip to try out different tips when I'm doing soldering. So something to consider for future. Soldering of the capacitors done. Now let's just clean up the legs by snipping the excess. Alright, I think at this point we should have just the lamp, I think, left to solder and the power. Yeah, so we're getting close, almost finished. Alright, ready for the lamps. I remember the instruction said the short side is positive and the long side is negative, right? I think that's what it should be. Alright, so let's just see if we can lay these flat, nice and neat, and drop some flux and then just solder them, these 2 sides together. Shouldn't be that difficult. Alright, let's see if I can run through this real quick. Another thing I also need, well actually I did order it and it's coming, I should get it soon, is soldering with flux in the middle, because like for soldering these lamps, for example, small ends, I don't think I shouldn't need to add flux to this. If I had the soldering with the solder wire with the flux in it, that would be very beneficial rather than adding the flux. Even though I don't mind the flux, it actually make it easier, because adding the flux here, it just flows onto the legs, easy, no bubbling up, just nice and smooth. But yeah, I did buy some solder wire with flux, so hopefully get that soon and make a difference. All done. I'm gonna now clean them up, see if I can remove some of this excess flux that I have on the board, because I mean it's a touch based project, so I want to make sure it's as clean as possible. So see if I can get out some of this flux with some alcohol on the brush. Alright, normally I don't know if it's a good practice, but normally whenever I use alcohol and I try to get the alcohol to evaporate fast, I use a microfiber, but also use the heat gun sometime at a low temperature of maybe 200 degrees Celsius. I don't know if that's a good practice to actually apply a little bit of heat to evaporate the alcohol quickly, or I don't know. Let me know if that's a good way to do it. Final step, time for the power. So this instruction said 5 volts DC power. This battery pack I have here is 3 volts, so I don't think that will work. So unless I'm going to add another 1.5 volt battery to this, which would, no, I think that would still give it 4.5, so that still wouldn't be enough. I'd have to add 2 more batteries to give it like a 6 volt or a 5 point something volt. Overall, 4 batteries together. But no, I think the 9 volt should be able to do it. So I'm gonna use a 9 volt on this, and then I'm gonna use one of these wires with the pins at the end, put the pin through the holes for the power on the PCB, and then solder it. Alright, that's the plan. So I bought this fun kit to practice breadboards, but it came with some the wires with the pin at the end with the male and the female side, and they're absolutely so effective for easy connection. And I think it's better to just use them to connect, for example, this ground connection on the PCB board, and also connect them to the battery. So I just have an easy plug in rather than having wires to twine up or stuff like that. So yeah, these definitely came in handy from that little phone kit. All right, got my wires, black wire, red wire. So now I'm just gonna push the pin through each of these holes and then just quick solder to fasten them. Alright, that's done. Soldering for the PCB power, nice and easy. So the next thing I did, to allow for an easy plug in and plug out rather than twining wires together to test this, I did a simple conversion with the wires that I use for the power port on the PCB. Both ends had the pin, I call that the male end. So I cut that one and I put a type of socket end on it so I can plug the pin in, and I call that the female end. So I put a female end onto the wire I use for on the PCB, and on the battery I have the male end. So when I'm done, I can just easily plug in and plug out rather than twining wires together. With everything done, all instructions followed, ready to plug in, testing time, fingers crossed, toes crossed. Let's go. Negative wire plugged in, or grounds if you want to call it that. Now I'm going to plug in the positive wire, and this is a touch test project, so need to get the gloves off, give it a test and see. Boom, bang, bang, there we go, working like a charm. Love it. Look at that. Come on. Yes. Let me test it again. Touch it. Hold on. Let me get rid of some light so I can see it better. Yes, looking good. All three lamps lighting up. Looking absolutely stunning. Love it. So it works. Let me see if I can dim it. What I can. Touch it and hold it down. I get the dim. Touch it and hold it down. I get it bright. Nice, very nice, looking really nice. How do I turn it off though? Look at that. Come on. Look at that. This is so sweet. I'm feeling so nice right now. Got it working on the first go. This is absolutely brilliant. Love it. All right, how do I turn it off? Let me see if I can turn it off. So no, holding it down all the way, don't turn it off. Tap and touch. Just a tap on it off. How I turn it on now? Let me see if I can turn it on. A tap probably should turn it on, right? Tap. Oh, there we go. Nice. Test it one more time. Turn it up. Hold it down, turn it down. Nice. So it's working perfectly. Working like a charm. Yeah, my daughter is gonna love this. Yeah, successful project. Took longer than I expected. Took longer than I wanted, but I don't mind. Once it's successful, once it's working, good to go. So on to the next one. And when I say on to the next one, people, I mean on to the next one. Take a look at this. We got projects galore. I got merch. I know what they call clothes merch, right? But I can call this merch, I don't know. Packages, merch, DIY projects. I have a lot of this. And I have more coming. So projects in the pipeline. But most of all, there's one particular project in this set of packages that I have right now. I can't wait to get my hands on. It's a digital clock that I have to make from scratch, and it's just absolutely, I just can't wait to get started with it. I just cannot wait. This is what it looks like. Check out the ICs, the resistors, the digital display. I can't wait to get on to this one. This one right here is looking like a soldering paradise. I don't know. This one is, I feel drawn to this project here. This digital clock. Yeah, I can't wait to get started with it. I actually have it right now, but I'm not gonna rush it. I'm gonna do another small one first, and then I'm gonna challenge this big one, and see if I can get it done correctly and working. I have a lot in the pipeline to cover, and I'll be sharing it all with you guys. So listen, don't forget to drop a like on this video if you enjoyed it. Even if you don't enjoy it, support the channel, drop a like, subscribe. Make sure you don't miss the next episode. I have a lot of exciting videos coming up. So I'm going to wrap it here for now. So until next time, big up yourself. My name is Lex. Peace out.